Welcome everybody to our notes on ozone. And we're going to start out today by looking at this cartoon. Why is everyone so afraid of the ozone? What do you see happening in this cartoon? You see that some are being burnt off? Well, a lot of people are concerned about the ozone layer. And it gets to the point where you walk outside and woof, you're on fire? Probably not. But it will cause other problems. And we'll talk about some of those health issues later on in the notes. So make sure you have a set of fill-in-the-blank notes, so as we go through these, you can, well, fill in the blanks. Here you can see what's happening. Got a couple of chickens getting grilled out. Look in the back of the buildings. When you see those buildings, what do you think of? It almost looks like it's hot and everything is dwindling down. Well, ozone is not necessarily related to global warming, and that's one of those myths out there. So we're going to explore that in these notes as well. So what is ozone? Well, the element oxygen is just O. Now, do we breathe O, or the oxygen, just one O at a time? No. We actually breathe the diatomic molecule of oxygen. It's two oxygens put together. So what is ozone? Well, ozone is actually O3. It's actually three elements of the ozone, so it's three oxygens all combined together. Air molecules. 2 million are normal oxygen, which makes sense. It's about 20% of the atmosphere. But just 3 are ozone. And that should tell you that that's common. We don't have a lot of it on our planet. Now, if the ozone layer brought down to the Earth's surface, air pressure and temperature, so if we bring it down from the stratosphere, the atmosphere, and we brought it down to the Earth's surface where it's under our pressure and our temperature, it would only be about 2 to 5 millimeters thick. So we're not talking about a large layer here. That's pretty thin. Now, the ozone layer is located in the stratosphere, which is 10 to 30 miles up. And the stratosphere, again, is one of the layers of our atmosphere. Now, the ozone layer protects life on Earth from overexposure to dangerous levels of ultraviolet light. It does so by filtering out harmful UV radiation from the sun. So we can see that these are the layers of the Earth. You got the troposphere, the stratosphere, the mesosphere, the thermosphere, the exosphere. And you can see where in this whole scheme of things the ozone layer would be. Again, it's in the stratosphere, approximately 12 to 20 kilometers above the Earth. Now, a diminished ozone layer allows more radiation to reach the Earth's surface. Overexposure to UV rays can lead to skin cancer, cataracts, and a weakened immune system. It also leads to reduced crop yields, and it could also disrupt the marine food chain. So there's lots of possibilities, lots of things that could happen if the ozone layer continues to be diminished and more UV radiation does strike the Earth. So let's talk about a few ozone hole myths next. First of all, the ozone hole often gets confused with the problem of global warming. Now, there is a connection because ozone contributes to the greenhouse effect, but the ozone hole is a separate issue. Ozone is a greenhouse gas if it's down here by us in the troposphere. But if it's up high in the stratosphere, it actually protects us from dangerous ultraviolet radiation. Now, the problem is there is no simple way to take all this bad ozone down by us and move it up into the stratosphere. Otherwise, that would be the perfect solution. There's no actual hole in our atmosphere as well. It is simply a lack of ozone in a given area. The ozone hole is defined geographically as the area within the total ozone amount that is less than 220 Dobson units. So, Dobson unit. What's a Dobson unit? A Dobson unit is just the unit that's used to measure ozone. Now, you see this 220 Dobson units. Some scientists will actually say anything below 225 would be considered a hole in the ozone. So when they say a hole, it's not an actual hole. It's just an area of low concentrations. So when people say there's a hole, usually when you think of hole, you think of there'd be nothing, no ozone. That's not true. It'd be like taking a look at someone who's bald. Well, are they really bald, or they just have a low concentration of hair on their head? Big difference there, especially for those of us who lack a little hair on top. So where do we study ozone depletion? What does this look like? You can see that there's snow. I know you look at it and you probably are thinking of Teletubbies. It looks a lot like their house. But no, you see here they have nice green grass. This was actually in Antarctica. Well, here you see another station where they study ozone. This is the Eureka Stratospheric Ozone Laboratory on Ellesmere Island in the Canadian Arctic. So they study it near the poles, both in the Antarctic and in the Arctic. One of the ways they'll get ozone concentration readings other than satellite is to take weather balloons. Weather balloons will go high into the atmosphere, and eventually these will come back down to the Earth, and then they can use these readings that they get to figure out what's going on with the ozone layer. What's the concentration? Now, the ozone layer, and we're talking about the one over Antarctica, it begins to develop in August, is fully developed by early October, and then disappears in early December. So each year it goes through a cycle. It seems to be times when there's high concentrations of ozone, and then there tends to be times in the year where there's low concentrations of ozone. Now, we first begin to notice the hole in the ozone layer over Antarctica in the early 1980s. So let's take a look at this. Again, let's look at a Dobson unit. A Dobson unit is simply a measurement of how thick the ozone layer would be if it was at sea level and at 0 degrees Celsius. So whenever you hear DUs, Dobson units, not meaning duh, it's not meaning do, it means Dobson units, and it's the level of ozone. And you can also see here, there's a scale, goes from 0 to 500, and later on you're going to see these on something called the false color plot, which will actually show you a graphic representation of the level or concentration of ozone. So here we can see one going through the cycle. See, it's January 31st, February 7th. It's going about every week. And the yellows indicate that, if I can get my cursor on here, it may not be working with, here we go with the animation. You can see right now it's white in the middle, and that just means they don't have data for it. A lot of times that happens when it's dark there. They just don't have the satellites, they don't have the data there. But now you can see it's starting to get purple. When it starts to get purple, you're down here in this range, and even got some of the pinks. And those pink would means that there's between 125 and 150 Dobson units. So this would be the so-called hole in the ozone layer. But as the year progresses on, we're in January 4th, 1990, we went back and we started over. That here is the concentration of this mustard color. This means there's 300 Dobson units. Now, there has been a 60% reduction of ozone over Antarctica from October to December since the 1970s. And there is a 100% loss of ozone in the 12 to 20 kilometer region above Antarctica in the polar vortex. So again, you might say, Mr. Rattoon, you just said there was no true hole. Well, there is no true hole where there's no ozone anywhere. Here it just says there's a certain segment of the atmosphere from 12 to 20 kilometers there's there's 100% loss. There's still some above it and below it, just not a high concentration. So here it says some ozone remains both above 20 kilometers and below 12 kilometers. So we can see that from approximately 1955 all the way through about 1995, ozone levels have gone down dramatically. If we drew in a line of best fit, you can see that things have definitely dropped. And these are monthly averages for October. October tends to be the peak time where concentrations seem to be the lowest. So when we look at these false color plots, you can see up here, look how there's a lot of blue in there. We can see that we're in this area. But as we progress through from 81 through 85, and then over here from 86 over, you can see that there's more purple as we move on, which would indicate there is indeed a loss. But do you notice that not every year is a loss? For example, 1987, look at the purple. 1988 was a better year. Then 1989, we tend to go back. So not every year indicates a loss. It goes up and it goes down, but some years are definitely better than others, and some years are worse than others. So here's a false color plot looking at 2007. Here's one looking at December 31st, 2010. Not that long ago. Here's one looking at 2010, and you can see the area that's outlined in purple here. Actually, it's got like a white line surrounding it. This would be the area of low ozone concentration. And this would be where scientists would consider there to be a hole in the ozone layer. And they call it the Antarctic ozone hole because if you look down below it, there's Antarctica. It lies right above Antarctica. So the white line at 220 DU shows the edge of the ozone hole. Now, what kind of effect does it have? Well, these are preschoolers in Puente Arenas, Chile, and they have to wear dark sunglasses during an orange alert day. An orange alert day means that there's high levels of ozone. Now, let me put it this way. There's high exposures of UV radiation. There's low levels of ozone in the atmosphere, so the amount of UV light, the UV rays coming down is tremendous. So these kids have to wear coats, they have to wear sunglasses to protect their eyes, and they can only stay out for a few minutes if they have skin that really reacts violently to the sun. So if you're one of these people here in Wisconsin, and if you go outside and it seems like you're outside for just a few minutes and all of a sudden you have a sunburn, you would only have a 7-minute recess because you'd have to go out, and because there's an orange alert day, you'd have to go in pretty quickly so you don't risk overexposure. So that does end part 1. Thank you.